Okay, everybody, we're back to talk about female reproduction. So in the female reproduction, the functions here are the production of ova, OVA, that's the plural form of ovum, OVUM, which means egg. Okay, and the production of the ova, that process is referred to as oogenesis, right? It's spelled oogenesis. It's not pronounced oogenesis though, it's oogenesis. Okay? And then, so that's going to occur in the ovaries. And then the rest of the reproductive tract is for the reception of the sperm. It's the site then where fertilization will take place, right? And the product of that fertilization is the embryo. And then the embryo stage lasts about 8 weeks. And at the end of the 8-week development, then it's known as a fetus. And so the uterus then protects the development of the embryo and also helps with the maintenance of the developing fetus as well. So that's gestation or pregnancy. It will also form the placenta, which then is the exchange organ between mother and fetus. And then the giving birth to the baby, the structures in the reproductive tract allow that. And then the other organs, the breasts are for nourishing the infant after birth by milk production. So these are all indications of a mammal. So, and I have bears here that are getting ready to hopefully fertilize an egg, hopefully for them. Right, and so these are the mammals that do this type of reproduction, right? So of course, we're talking about human physiology, so we are part of the class Mammalia. All right, if I get this working, let me get my laser pointer. There we go. All right, so so here now you can see in the physiology or the organs of the female reproductive organ, reproductive system. Everything is internal part. So here you can see, this is again a mid-sagittal section, so we're only seeing one side, but you can see one of the ovaries here. There would be a mirror image on the other side. Here's the fallopian tube. The fallopian tube then, and you can see it here, attaches to the uterus, which is here, and the uterus sits right above the urinary bladder. Okay, the opening to the uterus inside is called the cervix, and then the continuity between the uterus and the external environment, that's the vagina. So that's a muscular tube opening to the external environment. And so notice that here's the urinary bladder I mentioned before and the urethra. So we saw in the male reproductive system, there's an overlap in the reproductive system and the urinary system, but in females, there's no overlap. They're completely separate systems. So there's the opening to the urethra, to the bladder. Here's the vagina to the uterus, right? And then of course the anus attached to the rectum, right? From the digestive tract, right? Let's see. The primary reproductive organs then are the ovaries, right? They produce, again, the ova through oogenesis. And then they're also the endocrine glands. So they're going to secrete the female sex hormones, estrogen and progesterone, right? And so later on, we're going to see estrogen is very essential for the ova maturation and release. We'll look at all the hormone relationship. Estrogen establishes the female secondary sexual characteristics. It's also essential for the transport of sperm through the vagina to the fertilization site in the oviduct. And so another word for fallopian tube is oviduct. And so sperm actually have to travel all the way up through the vagina, through the uterus, through one of the oviducts to the site of fertilization is way up in this area where my laser pointer is. And then the estrogen also contributes to breast development in anticipation of lactation. The other hormone, progesterone, this is important in preparing a suitable environment for nourishing the embryo and the fetus within the uterus. Okay, and then progesterone, if pregnancy occurs, then it contributes to the breast's ability to produce milk. Okay? And so again, I mentioned most of the organs of the female reproductive system, it's internal. And then I think, you know what, I'm going to go over that a little bit later. So I'm going to halt for now. We have another slide on that. Okay. I want to focus so you can see a little bit, zoom in on the uterus and the fallopian tubes and the ovaries as well. So this is referred to as the reproductive tract. Again, this is the passageway for sperm to travel through the vagina. I mentioned the opening of the uterus is the cervix, and then the lumen of the uterus here, and then that opens to each of the fallopian tubes or oviduct, same word, and sometimes in other organisms or other mammals are called uterine tubes, right? So there's an opening for each one, and then the fallopian tube kind of curves around and lays just over the top of each of the ovaries. So here you can see a full one there. This structure here, this is not a tube between the ovary and the uterus. This is simply a ligament that holds the ovaries in place. Okay, because the ovaries really are not attached to the fallopian tubes. Fallopian tubes just kind of float around over the ovary there. Okay, let's see. Yep, make sure I got it all in there. So again, a little bit more. So the vagina is open to the external environment by the vaginal opening. So then the external organs, the external structures, you have folds of skin, the labia minora and the labia majora, right? There's the minora, there's the majora. And these are just skin folds around the vaginal and urethral openings for protection, right? And then up toward the anterior side is the clitoris. So, and that is embedded within the folds of the labia minora as well. And so that's the organ for sexual arousal and also to trigger some of the glands and they produce their secretions. And then the vulva is just the collective term for the female external genitalia. Let's see. Okay. I just want to make sure I got everything in there. So let's talk about oogenesis. So if you watch the male reproductive system first, we talked in depth about spermatogenesis. And so the creation of the egg through oogenesis is very similar. Pretty much the identical steps of the chromosome replication and division. So this happens through meiosis, but it's the timing and the end result that's very different. And so you can see that in this chart. Spermatogenesis can be accomplished within 2 months, but it's continuous. Oogenesis can take anywhere from 12 to 50 years to complete on a cyclic basis from the onset of puberty until menopause, right? Spermatogenesis, an adult male can produce several hundred million sperm each day, about 500 million sperm each day. But in oogenesis, what we're going to see is that the female are born with a limited supply of germ cells. And so, and they're non-renewable. So we're going to see later that we actually we're born with about 2 million germ cells, but by the time we reach puberty, many of those just degenerate. And we're left with about 400,000 at puberty. And then during our reproductive years, where we're ovulating once a month, we ovulate about 400 to 500 eggs in our reproductive years before the onset of menopause. So we get a big reduction of eggs over time. And then what we'll see next, I'm going to show you next, is if you remember when you saw the primary spermatocyte, that was the diploid cell that begins to divide by meiosis to produce the spermatids. And when they do, just like you learned in general bio, then one diploid cell divides to produce 4 viable spermatozoa. But it's different in females. Each primary oocyte, which is going to be 2N, that's going to divide by meiosis. But with each meiotic division, when one cell divides into 2, one of the cells is going to degenerate. And the other cell is actually, they divide unequally, and it's going to get most of the cytoplasm and organelles and things in the viable egg. So really the meiotic division of one primary oocyte yields only one mature ovum to be available for fertilization. Okay, and that's what you see here. So again, this is the process of oogenesis. And so the oogonium are produced in the fetal ovaries. So we're looking at the life cycle of one person. So before they're born, before this girl is born, and the ovaries are developing, the oogonia develop. And these are the undifferentiated germ cells, the diploid cells. And they divide mitotically and give rise, I think I used the small number there. It gives rise to 6 to 7 million oogonium by the 5th month of gestation, of her own gestation. So when she is just a 5-month-old in the womb, she's producing about 6 to 7 million oogonia. Okay, and so this is the mitotic proliferation. So it divides by mitosis to produce those 6 to 7 million. Right, and then during the part of fetal life, early steps of meiotic division occurs, but it doesn't complete. So many of these cells will start to go into prophase 1. Remember, that's the first step in meiosis 1, but it's going to be arrested. It won't continue until puberty hits. So, but at that point, they're called primary oocytes. And again, they're still diploid because we've only seen mitosis occur right now. Okay. And so it's actually here that, again, by 5th month of gestation, they produce 6 to 7 million. By birth, they're probably down to about 2 million. And then by puberty, we're probably down to about 400 to 500,000 primary oocytes. Okay. The other thing I wanted to mention on this is, again, once these start to divide and complete meiosis, that starts at puberty, and that starts the ovarian cycle, which is going to occur once a month. So we're going to refer to the ovarian cycle now and see what happens inside of the ovary and the structures that develop inside the ovary. But I want to continue and just kind of show you the change in the meiotic division here. So once the ovarian cycle is stimulated, again, once a month, starting at puberty, then the primary oocyte, a few of them, so about 4 to 6 in each ovary, will start to go through meiosis 1. And when they do, and they divide, they're going to divide unequally. So again, one cell is going to get all the rich cytoplasm. The other one is not going to get much of anything. And it may or may not go through a second meiosis, but in either case, they just disintegrate. Okay. The secondary oocyte, then once it starts to go through its second meiotic division, so realize as a secondary oocyte is haploid now because we just went through meiosis 1. Okay. Once it goes through its second meiotic division, and it doesn't do that unless it's fertilized. So the second meiotic division occurs once fertilization occurs. That's why there's a little sperm there. But when that happens, it divides unequally again. And so the ovum that's that gets fertilized, that gets all of the cytoplasm and all the rich machinery needed for the maturation of the offspring. And the second polar body, again, just disintegrates. That one goes away. So from one primary oocyte, we end up with one mature ovum. And in contrast to males with one primary spermatocyte, we ended up with 4 spermatids. Okay, so it takes a lot of energy to produce the eggs, and so again, we're only going to release the eggs once per month. And so that sets us up for, so actually, this is starting to show the ovarian cycle. This is what's occurring inside of the ovary. I almost forgot about this slide. But just to kind of reiterate what I showed you here, now you can see what's happening inside of the ovary itself. Let me move this little picture. There we go. And so here's the ovary. And so what happens inside of the ovary, there are these clusters of primary oocytes. And so we'll add the hormones onto it. They'll get triggered to start to develop. And only about 4 to 6 at any one time will start to develop. Because again, there's about maybe 200,000 in one ovary once puberty starts. So each month, about a cluster of 4 to 6 will trigger to go through their first meiotic division. And while that's happening, so here are the primary oocytes that are going to start to go through meiosis. You see that the cells surrounding it begin to organize and develop what are called follicles. Okay, and so these cells inside of the ovary are called granulosa cells. Okay, and so they organize and form a single layer of cells around the primary oocyte. And so now this is referred to as a primary follicle. The oocyte plus the granulosa cells make a primary follicle. Okay, and so this primary follicle, again, and this is all going to be stimulated by hormones. We'll add that on in a minute. After development starts, then a couple things can happen. It'll continue to develop into a secondary follicle, which is this one, or it'll degenerate. And that's usually what happens. So I said about 4 to 6 develop into primary follicles. And you can see as it develops, it'll develop more layers of cells, more granulosa cells. And the primary oocyte is still going through its meiotic division here. But so out of those 4 to 6, maybe only 1 to 2 make it to a secondary follicle, right? And so the other ones just degenerate, right? They form a little scar tissue, okay? So then as hormones are stimulating the secondary follicles to develop, there's usually one that develops more quickly than the other one. And so only one secondary follicle continues to become a tertiary follicle, or what's called a primary or a mature follicle. So again, notice during the secondary stage, more of these cells develop, the granulosa cells, they form that ring around the oocyte, right? And this is still a primary oocyte going on in here in the secondary follicle. But notice that fluid now is beginning to develop between the other granulosa cells. And then on the very outer edge are thecal cells. And so this whole structure, again, is called the secondary follicle. Okay, and here's your oocyte inside of there, still hasn't completed its first meiotic division yet, so it's still a primary oocyte. Then again, only one of these secondary follicles continues its maturation. It gets more fluid in there, so that space now is called the antrum. Right? It's got more thecal cells around it. This is a mature follicle, and now it's ready to start its second meiotic division. This is a secondary oocyte here, but it arrests, it stops. Okay, and so this mature ovary, and so basically these follicles are kind of moving around the ovary, and when the mature follicle gets really big, and it pushes on the wall of the ovary until by hormone signaling, the wall of the ovary will actually rupture, and the secondary oocyte, along with a coating surrounding the egg called the zona pellucida, and along with a ring of the granulosa cells called the corona radiata, that gets ovulated and heads toward the fallopian tube. But the rest of the follicle stays behind, and you can see it moves through the ovary, and it becomes this structure called the corpus luteum. Okay, and it's a corpus means body, luteum means yellow, and it's literally a yellow body inside of there. But this becomes an endocrine organ, an endocrine gland, which then keeps the uterus in the perfect condition to receive a fertilized egg. Okay, and let me go a little bit further. Let me go to the next slide. Oops, there we go. So again, just to kind of reiterate what we just said, so during oogenesis, so inside of the follicle, as that follicle is developing, it's the primary oocyte that's completing its first meiotic division. Okay, so that's what you saw occurring. It's starting to go into this meiotic division. So remember, you have several phases to go through, right? Prophase, prophase, metaphase, telophase, right? So that's what's happening all throughout here as these follicles are developing. Okay, and again, then the secondary oocyte develops and the first polar body just degenerates. So here we are with the secondary oocyte in a mature follicle. So all of this maturation of the follicle is occurring during this segment here, but you're only seeing the egg at this point. Okay, it's the secondary oocyte then that will get ovulated. All right, so here we are, here it is getting ovulated. And if there's a sperm available in the fallopian tube, a sperm, several sperm, then it'll start to go at that penetration of the sperm will trigger the second meiotic division. Right. And so again, the other polar body that results will degenerate and end up with the sperm inside of it and the nuclei fuse. That's fertilization. So now this is a single cell diploid cell called the zygote. Now it's the zygote which will divide by mitosis to produce the embryo. Okay. So this is what's going on with the ovarian cycle. Okay. And again, here's another picture kind of showing that. There are your primary follicles developing with the primary oocyte inside. The secondary follicles develop. There's usually one or two that continues, and then only one continues to become the mature follicle. So the follicle itself, again, is the egg and the cells surrounding it, the granulosa cells and the thecal cells. Okay, and but it's the egg inside that's going through meiosis. Okay, and by the time it gets to the mature follicle, also called a Graafian follicle, then it's a secondary oocyte, and it's just ready to start its second meiotic division. And it won't do that until after ovulation, and then it'll start to go into its second meiotic division if it gets fertilized. But again, what's left behind in that mature follicle, the cells, the granulosa cells and thecal cells, they will reorganize and they will form this corpus luteum. And this corpus luteum now will secrete hormones. Okay, so all of this is triggered by hormones, and these hormones then are also going to influence the uterus. Okay, let's see. So the ovarian cycle itself, I'll show you a little bit later a chart kind of showing the secretions from the hypothalamus and so on, but it's a little bit easier to see in this picture here. And you know what? I don't know why there's this, yeah, I don't know why there's that box there. I'll see if it's on your slides in the canvas, but you can see anything you need to see is on this picture. But I'll go back here so you can see these. Because the ovarian cycle, what I just described, those eggs going through meiosis and the follicle developing, that's driven by hormones. And it takes about 28 days. And that's what you see on the scale down here, day 1 to day 28. Now, it's about 28 days because every woman is different. So every woman's cycle, instead of being 28 days, it could be 26, be 24, it could be 32, right? So each woman is different, but even each woman herself is different each month. So 1 month, the cycle might be 28 days. The next month, it might be 26 days. The next month, it might be 30 days. So it's pretty variable. But to make it easy, we go on a 28-day cycle. Okay, so the first half of the ovarian cycle is referred to as the follicular phase. This refers to the follicles that are developing, and that's what this picture is showing you here. So this is what I was describing while the primary oocyte is starting to go through meiosis and the follicles are developing. So that's why it's called the follicular phase. So about day 0 to just before day 14, if we're going to stick to a 28-day cycle, again, just to make the numbers easy, this is when the follicular phase is developing, and those granulosa cells are starting to proliferate, causing the larger follicles to develop. Okay. Now, why are they doing that? Because the hypothalamus will signal the anterior pituitary gland by the release of gonadotropin-releasing hormone, same in the males, to start to release more follicle-stimulating hormone. Remember, we said it was named for the function in the female body, right? And so that's what follicle-stimulating hormone does. Its receptors are along these granulosa cells, and so it causes the development of the follicle and spurs the oogenesis as well inside. Okay, so the rise in follicle stimulating hormone is what causes these follicles to grow larger. And again, as more and more granulosa cells and thecal cells begin to develop, they release estrogen, which is a positive feedback onto the anterior pituitary. They also cause the insertion of more receptors for follicle stimulating hormone. And some follicles, remember I said we start with maybe 4 to 6 developing, but we end up with only 1 completing the development. That's because some of those cells are faster at inserting the receptors. So 1 ends up being the most sensitive to follicle stimulating hormone. And that's the one that continues on to become the mature follicle. Okay, and so you can see that because only 1 is becoming mature, then it's getting bigger. This estrogen then is now going to stimulate, as more and more estrogen rises, it's going to stimulate the anterior pituitary, again, through the stimulation of from the hypothalamus, from gonadotropin releasing hormone. It's also releasing LH. You can see that rising. But it's the estrogen that's really increasing because the follicle's getting better, that we start to see more and more LH occur. And LH isn't having an effect yet. But when we get the surge of estrogen, because the mature follicle is so big, it's producing a lot of estrogen, that triggers a surge of LH. And LH, the surge, causes the ovulation. And you can see it there. I flipped to this one so you could see the picture here. Okay, so again, the surge of estrogen, because the follicle is getting very large, there's a lot of cells releasing estrogen. That causes a surge of LH from the anterior pituitary that happens right about day 14, just before. And so after the surge of estrogen, within about 24 hours is when you know you're going to ovulate. Okay. And so it's the LH that causes the ovulation or the rupturing of that ovarian wall and the release of the secondary oocyte. Okay. So the follicular phase, let me go back here. right? It operates on the first half of the cycle, and it is the development of the follicle, follicular phase, development of the follicle. So you need to know the function of FSH on the developing follicle, and then the function of LH and how we get that surge to cause the ovulation, right? And then also layer on it the increase in estrogen because of the thecal cells secreting increasing amounts of estrogen as the follicle begins to grow or continues to grow, right? So we just had our event called ovulation. That's about day 14. That puts us into the second phase of the ovarian cycle called the luteal phase. Okay, the luteal phase. All righty. So that's about day 14 until day 28. Okay, and then we're going to talk about what happens if there's pregnancy or not. So luteal phase, luteal, is named for the development of the corpus luteum, right? So the follicular phase was the development of the follicle. Well, the follicle that gets left after ovulation becomes the corpus luteum. So that's our luteal phase. So these are about the last 14 days of the cycle. And you can see that, remember that it was the follicle that was secreting estrogen. Well, there's a big drop off of estrogen because now the mature follicle left behind is reorganizing into the corpus luteum. And it takes some time to do that, and it'll eventually reorganize and continue to produce estrogen. You see this rise here. Okay, but the other thing that the corpus luteum now releases is the other hormone, progesterone. Okay, you can see here FSH and LH are on the decline. And that's basically now a negative feedback of progesterone on the anterior pituitary to reduce the release of LH and FSH. So you can see those go low. But the luteal phase, the corpus callosum or corpus luteum develops, and now it's an endocrine secreting gland itself to continue to secrete estrogen, but also progesterone. Okay, and so you can see it takes about 4 to 5 days as it increases in size. But then if there's no fertilization that occurs, let me move my picture here. If no fertilization occurs, then the corpus luteum will just degenerate. Okay, after 14 days of formation. And then if that degenerates, you can see that progesterone really declines. That takes the negative feedback off of the hypothalamus and the anterior pituitary gland, and we start all over with our ovarian cycle. So FSH rises, and so new primary oocytes begin to develop with the primary follicles, and so on and so forth. It happens all over again. If pregnancy does occur, then the corpus luteum is maintained. And the reason why it's maintained is because by the time then the fertilization occurs and the zygote divides, it divides as it moves through the fallopian tube. By the time it reaches the the uterus itself, it's an embryo of anywhere of about 60 to 150 cells. Those cells then begin to produce a hormone called human chorionic hormone that acts on the corpus luteum to maintain the corpus luteum. Then if the corpus luteum is maintained, progesterone stays high all throughout pregnancy, okay? But again, no embryo, then there's nothing to maintain the corpus luteum. The corpus luteum just regresses and then becomes the scar tissue in the ovary. And you can actually see the scar tissue in the ovary for each cycle of corpus luteum that degenerated. Okay, so that's the ovarian cycle. So remember, ovarian cycle is occurring in the ovary, and it has to do with the developing follicle in the follicular stage and the corpus luteum luteal phase. And then it also is determined by the amounts of FSH during the follicular phase, LH causing ovulation, and then progesterone and estrogen produced during the luteal phase. Now, this estrogen and progesterone being produced all throughout the ovarian cycle is also acting on the uterus and causing a uterine cycle at the same time. Okay. All righty, and that's see down here. Let me move my picture again. So this shows everything together, right? So here's what we just saw with our FSH and LH causing the follicular stage and the luteal stage of the ovarian cycle. So these two panels up top show the ovarian cycle. The middle panel shows the amounts of estrogen in green and progesterone in blue. But now we want to see how that acts on the uterus, okay, causing the uterine cycle. Right. Oh, before I do that, I forgot about these slides. I'm sorry. I should have printed out all these so I could see the sequence. So this is the flow chart of showing the gonadotropin releasing hormone stimulating the anterior pituitary, again, to affect the, to release follicle stimulating hormone, which is going to cause the maturation of the follicle. This is the follicular stage. Luteinizing hormone then is going to cause the ovulation, right? The developing follicle will actually start to release more and more inhibin. And so inhibin will selectively act on the follicle stimulating hormone cells of the anterior pituitary to reduce that. Because once we get this started, we don't want to keep stimulating more follicles to develop. We can only really have one follicle develop, right? And then again, I mentioned this before, is there's rising levels of estrogen that also is a negative feedback on the anterior pituitary and the hypothalamus to slow down the release of these hormones as well. Okay. Here you see, again, the surge in LH, which causes the ovulation. And again, more high levels of estrogen, negative feedback on the hypothalamus and the anterior pituitary gland. And again, that's because now we've got ovulation. We don't want to stimulate any more follicles again. We want to see what happens with this egg. Because if this egg gets fertilized, then any stimulation of more follicles is a waste of eggs. So the body kind of bets that this is going to be fertilized. Okay, so I don't know which helps you better to see a chart like this, the flow chart, or I like the other chart to kind of compare the hormones along with the ovarian cycle. And then we're going to see what happens with the uterine cycle. I found this picture. This shows a nice shot of the ovary and how the fallopian tube isn't a direct connection. So when that ovulation occurs, that egg actually just kind of in the egg. But the fimbriae, these finger-like structures on the end of the fallopian tube, again, this is all fluid filled. They're kind of waving around and they draw a suction of the egg up into the fallopian tube. Okay, and the sperm have been traveling through, and the sperm have to go all the way over beyond this bend. Fertilization occurs about here. Okay, and I'm going to show you more on that in just a minute. And I'll tell you later how the sperm know which way to go, which fallopian tube to go in, because while each month, each ovary they're both going through the ovarian cycle. But again, one not only is the winner within the follicles of its own ovary, but over the other ovary as well. So one usually gets the most receptive to the follicle stimulating hormone and then luteinizing hormone, and it gets ovulated out, where the other one just doesn't reach maturity in time, for the most part. You can ovulate both at the same time, and that's usually, and if they both get fertilized, that's usually how you get fraternal twins, twins that aren't identical to one another. Okay, I'll tell you later how you get identical twins. Okay, but so I mentioned now the ovarian cycle is causing the release of estrogen and progesterone. Again, estrogen coming from the follicles, and then both estrogen and progesterone coming from the corpus luteum, but mainly progesterone now. So those not only have the negative feedback to the hypothalamus and anterior pituitary, but they're also stimulating a cycle in the uterus, right? So recall from anatomy that the uterus has 3 layers. You have the very outer layer is the perimetrium, and that's really just connective tissue to connect the uterus to the surrounding organs and structures in the abdominal cavity. The middle layer is the myometrium. That's the smooth muscle layer, 3 layers of that. That's going to come into play for contractions to help birth the baby, and also to expel the inner lining during menstruation. And that has to do with the endometrium. That's the inner lining here. It's epithelial tissue, and it's hormonally responsive. It gets real thin and then gets thick and gets thin again. And what we're trying to do is grow it nice and thick and time that thickness of the endometrial layer with the ovulation of the egg, so that when fertilization occurs and mitosis occurs to develop the embryo, that by the time the embryo reaches the uterus, it has a nice, thick, secreting endometrial layer that's going to be a great environment for the embryo and then uterus to develop, or embryo and then fetus to develop in. Okay, so the development of the endometrial layer is what's referred to as the uterine cycle. Okay, so here you can see this graph now is kind of showing the thickness of the endometrial layer, right? And again, we want it to be really thick and have all these glands and things that are secreting things for a fertilized egg, for an embryo to arrive. But if the embryo doesn't arrive, then we break down that inner lining and we slough it off. And that starts what's called the first phase of the uterine cycle, is menstruation, right? Uterine cycle is also known as the menstrual cycle. So just be aware of both terms, okay? So again, just coinciding, and I'll probably show that other graph. I think I meant to move that to the end of this. Coinciding with the ovarian cycle, at day 1 of the ovarian cycle is when menstruation starts. Okay, and so basically what's happening is that endometrial layer that was really thick is the blood vessels are receding and the endometrial layer is pulling apart, and then the lining just sloughs off. It gets released out of the uterus via the vagina. And so you have all of these blood vessels that were in there and they break off, and that's the blood that's coming out. So it's tissue and blood. So the first day of menstruation is the start of the new cycle. Okay. So what's starting this, we go back here, right? We're down here, is the reduction of the corpus luteum and the rapid decline of progesterone. With progesterone gone, that triggers the menstruation, right? So this over here, it says 23, is the same over here, okay? So that triggers menstruation. There's very low estrogen and progesterone. So without those 2 hormones, there's nothing causing the endometrial layer to stay thick. So it starts to slough off, okay? Well, while that's happening, again, the follicles are developing. And as the follicles are developing, remember, they're releasing estrogen. So now we see a rise in estrogen. And with that rise in estrogen, we get a reorganization of the endometrial lining. It starts to grow again. So menstruation stops after about 3 to 5 days. Okay, menstruation stops. And then we get into the second phase of the uterine cycle called the proliferative phase. And this is because estrogen is now, the receptors are on the cells of the endometrial lining, and it's causing them to grow, right? And so that's your proliferative phase, is the growing of the endometrial lining, okay, because of estrogen. Okay, so peak estrogen levels trigger the LH surge, and then you get your ovulation. So by the time the ovulation occurs, that puts us into the third phase of the uterine cycle. That's called the secretory phase or secretory phase. Think of secrete. That's because the lining of the endometrium now is at its thickest, really thick. It's got glands that are secreting supportive fluids for an embryo to come. It's got these blood vessels that are in there just supplying nutrition to the lining. And this is being maintained by the progesterone being released from the corpus luteum, because we're in the luteal phase now. We're after day 14. So it's the luteal phase for the ovarian cycle. It's the secretory phase for the uterine cycle. Okay, make sure you have those phases separate between the ovarian cycle and the uterine cycle. Okay, so with high progesterone, we're into the secretory phase. Okay, and you can see endometrial glands actively secreting glycogen. That's a storage form of glucose. So that's available for this developing embryo if it comes, right? And if it does come, remember the embryo starts to release a hormone back to the corpus luteum to maintain it. And throughout pregnancy, this will be maintained, this secretory phase. But if there is no fertilization, no implantation, then there's no signal back to the corpus luteum, so it will degenerate. That causes a decline in progesterone. So that causes the secretory phase to become unstable and will trigger the menstruation. So the decline of progesterone triggers menstruation. So again, maybe go back to this one. Okay, and again, that there's menstruation, low estrogen and progesterone because there's no corpus luteum. Okay, menstruation lasts about 3 to 5 days. By that time, back in the ovarian cycle, we're in the follicular phase and our follicles are developing. As they develop, they secrete estrogen that rises, that triggers the proliferative phase in the uterine cycle. So the endometrial lining proliferates or grows. Okay. Then after ovulation, the corpus luteum now secretes high amount of progesterone, and that puts us in the secretory phase, and that maintains this thick endometrial lining. Okay, but if no implantation, no fertilization occurs, then the corpus luteum degenerates, progesterone declines really low. Now there's no signal to keep the endometrial lining thick, so it sloughs off, and we're back to day 0, and both the ovarian and uterine cycles start again. Okay. Alrighty, so you guys need to be able to relay that information back to me. All right. Well, so this goes on until about, from an age about 11, 12, 13 till about between age 45 to 55. Okay, those are the reproductive years of a woman. She simply runs out of cells, out of egg cells after a while. And so that triggers the entering menopause. So if you run out of egg cells, then you don't have any structures to produce a lot of estrogen, right? And so that's going to stop the menstrual cycle, okay? And it's also thought that there's, in that midlife at about age 45 to 55, changes in the hypothalamus may trigger the onset of menopause. So this isn't completely understood yet how this happens. Right? And then you'll see increasing irregular cycles, dwindling estrogen levels. But estrogen is also keeps bones strong. So this is why then women might supplement with estrogen. You see your doctor and determine what you need to do in order to keep your bones healthy during your postmenopausal years. Okay, but let's say fertilization occurs, right? So here we're going to get ovulation. Only one of the ovaries usually ovulates, could be 2, but 1. Okay, so the egg will be here and the sperm needs to find it. So the yellow arrows indicate this path of the sperm. So again, sperm gets ejaculated into the vagina at the opening of the cervix. So they have to swim. And like I mentioned, usually only one ovary releases the egg. So how do the sperm know which direction to go? Well, the egg is releasing a chemical that the sperm can sense. And so the sperm just simply follow concentration gradients, and that tells them which way to go. Okay. Again, if both go, then there could be enough sperm, they split up and they both go in each direction, and you could fertilize in both areas and then have both fallopian tubes have an embryo reach into the uterus, and the uterus can accommodate two growing embryo and later fetuses. Okay. So again, the oviduct is the site of fertilization. And so again, usually up in this area called the ampulla. And fertilization must occur within 24 hours of ovulation, right? And sperm usually survive about 48 hours, but they can survive up to 5 days in the female reproductive tract. So beware of that if you're trying to control your reproduction. Okay. Let's see. And what can also help the movement of the sperm are contractions of the uterus. So that upward contractions of the smooth muscle in the uterus and the oviducts can actually help draw the sperm in. Okay, and again, the eggs release a chemical that attracts the sperm. And I just remembered, I have it written down here. The chemical is called allurin, A-L-L-U-R-I-N. It's like alluring, like, come to me sperm. I think that's a funny name for it. Alrighty, so again, so with fertilization occurring, let me move my picture there. The sperm, so several sperm are necessary for fertilization to occur, but only one sperm fertilizes. So here's what I mean by that. Again, here's that secondary oocyte, and it's got that kind of a jelly coating around it called the zona pellucida, and then it's got the cells around it called the corona radiata. So the sperm have to, it's a pretty thick layer. The sperm have to use that acrosome cap. Remember, it releases enzymes to wear away those cells and wear away the zona pellucida. But the sperm get pretty tired when they're literally beating their heads against these cells and wearing them down, and one can't do it. So you can see on this picture up here, there's a whole lot of sperm. And as this one wears away and he gets tired and moves off, this other one might come in and work in that same area. Well, they're working all over the place until finally one penetrates. And as soon as his head penetrates the cell membrane, then the ovum surrounding membrane releases a chemical that repels the rest of the sperm, because you can only have one sperm fertilize an egg, right? Because again, the sperm has 23 chromosomes, the egg has 23 chromosomes, and humans can only have 46. If two sperm get in there, then that's too many chromosomes and it's simply not going to develop. Okay, so again, once the sperm gets in there, really just his head gets in there, meiosis then is completed in the ovum, and then within an hour, the sperm and the egg fuse. And now the fertilized ovum is called a zygote because it's got a single nucleus that's diploid, and it's a single cell now. Okay. And so here you can see kind of the rest of what happens after fertilization. So here was our ovulation. Here is the oocyte inside of there. It's moving through to the ampulla. Now there's fertilization. Now we start counting down. That's day 0 of conception, right? And so the fertilized egg becomes a zygote, and then it begins to divide by mitosis. Now we have mitotic divisions because we're going to just make more cells, but retain the number of chromosomes in each new cell. right? And so as it moves through the fallopian tube, it takes several days. It takes about a good 10 days for it to reach the uterus, right? So this 10 days is the luteal phase inside of the ovary, right? So again, after ovulation, now you've got the corpus luteum developing. And so you need at least 10 days for the luteal phase. That's why women, as they get older and approaching menopause, the uterine cycle might get shorter and shorter. And if it does, then that won't be enough time, even if she does get an egg fertilized, it won't be enough time to build up the lining in time for fertilize or the embryo to arrive. And again, the embryo that arrives is called a blastocyst, and it's about 60 to 150 cells, just kind of a sphere of cells. And but then as it arrives, the endometrial glands provide the initial nutrients. That's why we want that real thick endometrial lining in the secretory phase. The placenta then develops both from maternal and fetal tissue. And again, that's the kind of the filter between the blood supply of the mother and the baby. As the baby's supply develops, baby's blood system develops, cardiovascular system, but the blood doesn't mix there. It's just an exchange of nutrients and gases and things. Okay. And I think that's about it. That's the last slide that I have for you. Oh, wait, I think I'm lying. Birth control methods. So I showed you the vasectomy in men, which is the most widely used birth control method regarding men. In women, there are a lot of different types of methods. And so I found this chart from a clinic and put this up here for you. And so there's most of the ways that work best are hormonal methods, and it's based on those hormones that get released during the ovarian cycle. So if you remember that during the luteal phase with high progesterone, that keeps the uterus at a thick membrane, and also with high progesterone, then there's low FSH and LH, which means that you're not stimulating more follicles to develop. So the body with either hormonal methods on implants or with the pill, what you're doing is you're keeping and maintaining a high progesterone level. So you're kind of fooling the body into thinking it's pregnant. Okay, and but you have to, especially like with, have to make sure that you're keeping a constant level of progesterone. And there's other hormones in here. Progesterone isn't the only one, but you're keeping a constant level so that if it declines at all, you might trigger the ovarian cycle again. And then pregnancy could happen. So you want to make sure that you're keeping on a very strict schedule if you're using any hormone methods. And there's other, like the pill you have to take every day, the shot every 3 months. So there's different ways to do that. And there's so many different formulas because every woman's body is different. So you got to work really closely with your doctor in order to find one that works for you. And if you get on one of the hormonal methods and you always feel irritable or sad or something, then it's not the right formula for you. Don't just suffer. Go back to your doctor and work with your doctor, and she or he can figure out, which pill or which method is the best one for you, because you should feel good. These hormones have other effects in the body. So I actually really wish they wouldn't call them birth control, because they're really more about women's health. And so they have other effects, because even women who can't have children, some of them go on to these hormonal methods to help regulate temperature and lots of other things going on in the body. So these hormones are really just a way to help with women's health, not just birth control methods. But that's how that works. That kind of, again, mimicking, going back here to this slide, just trying to keep the progesterone levels high and estrogen, and there's a mixture of hormones in there, so that you don't stimulate the follicular stage again. Without that, you don't get ovulation, you don't have an egg available to be fertilized. Okay. Another one, tubal ligation. This is where they can tie these tubes so that sperm coming in here, they have nowhere to go. They can't cross where this gets tied on both of them. So you can just block the entryway of sperm getting to where ovulation is. So you still have your regular cycles. It's just that sperm don't have a way of getting there. So that's major surgery though. And usually women who do that, it's after they've already had given birth, and the doctor's already in there. So they say, go ahead and do that if they've decided this is the last kid. But it's more difficult to reverse. A vasectomy you can reverse. They can put the vas-deferens back together, and so those can actually be reversible. All right, there's a lot more to it, and we don't need to get that involved, but I just wanted you to kind of get some of that initial information, and you'll take that with you to your transfer programs. Okay, that's it, everybody. Thank you for listening.